So in this video, I'm going to talk a little bit about mechanism basics. So mechanisms are how we use curved arrows to show how reactions take place and how bonds are formed or broken. So in this example, which is similar to some ones we've done in class in a workshop, everybody has full octets. You can assume that, and you want to fill in the charges. So one I've already filled in, I minus. But of course, we'd have to balance the charge on either side. So there's an O minus on the left-hand side and the reactant side. The other thing I always recommend to do is number the atoms. 1, 2, 3, 4. We'll call iodine 5, oxygen 6. We won't necessarily have to number those other carbons over there. Make sure we number accordingly on the other side. There's iodine 5, and there's oxygen 6. So number those atoms, add in lone pairs. I've drawn in the hydrogens and the alkenes. Sometimes it's also really helpful to draw in the hydrogens on the other side as well. The other thing I like to do is to kind of give myself a guide. So what bonds are going to be formed and what bonds are going to be broken? And this helps me know what curved arrows, what mechanism arrows I need to use. So I look at this, I can see I need to make a pi bond between carbon 2 and 3. So I'm going to say I'm going to need to form a pi bond between C3 and C2. It also looks like I'm making an OH bond over here. So an OH, a sigma bond between a hydrogen and oxygen 6. What bonds am I breaking? So it looks like over here, the carbon iodide bond is breaking because the iodide is no longer there on carbon 2. So we're breaking a sigma bond between C2 and iodine 5. Again, the numbering is just, the key is to be consistent across either side. This has nothing to do with nomenclature. And then the one that's tough to see is if you look at C3, C3 had 2 hydrogens, and now all of a sudden it only has 1. That's the one that's harder to see. And that's where this H right here is one of these 2 H's here. So that oxygen grabs that. So that's the other bond we need to break, is a sigma bond between C3 and that H. The other thing I like to do in each step is identify the nucleophile and electrophile. So in this first step, of course, nucleophiles are electron rich. So a nucleophile is usually a negative charge. That's where we start our arrows. So in this one, I see something on the left-hand side. I think O6 is my nucleophile, right? It has a negative charge. So what's going to be my electrophile? The electrophile is the thing that the nucleophile reacts with first. So the electrophile, in this case, is actually going to be that H off carbon 3. That H off carbon 3. So this is all going to happen in one step. So let's see those arrows. Grab those 2 electrons from O6. I'm going to grab that H, double-headed arrow. The 2 electrons in the CH sigma bond are going to break. We're going to form that pi bond between C3 and C2. At the same time, the sigma bond between C2 and iodine 5 is also going to break. Those electrons are going to go there. So now this is a good way to double check to make sure we've done what we said we're going to do. Did we form a pi bond? Did I show an arrow showing that pi bond being formed? I did. So you can check that one. Did I show the OH sigma bond being formed? I did. That's what this arrow shows. Very good. You can check that one. Did I show the iodine carbon bond being broken? This arrow showed that. Excellent. And then I show the C3H bond being broken. And again, that arrow showed that as well. So I checked it off. So things I like to do. Add lone pairs, add your charges. Draw in the hydrogens. Right? Number your atoms. Write down bonds formed and bonds broken. This will help you guide what arrows need to be done and make sure you check them all off. Think about where the nucleophile and electrophile is for each step. Nucleophile is where electrons density starts. Electrophiles is electron deficient. Arrows always start at nucleophiles. Where the nucleophile reacts with first, that atom is the electrophile. The nucleophile is electron rich, that's the atom that's a nucleophile. Follow these kind of rules and it'll be really helpful to be when you can see a starting material and a product and then you have to fill in the arrows. It'll be really helpful.